Hello everyone. In this video, we are trying to see about hardware programming. So with 8051, we have already seen many videos with respect to hardware programming with 8051 microcontroller using our Keil software. So here we are going to access your ports with the help of your LEDs, and after that you are going to create a delay, and after that you are going to incorporate the concept of interrupt inside your programming. So for this, we have to understand about kit a little, and after that we will be understanding about ports. We will be understanding about how to create a delay using a timer. All those things we have already seen in our previous videos, but quickly we will have a glance of how to create a delay and how to use the ports and other things. So for this video, we have been given with a question. So write an 8051 assembly language program with timer 0. With timer 0, you have to enable the pin 1.1 for 1 second to turn on an LED. So we are having two LEDs. So in that we have already seen blue LED is there, and after that we are having a red LED. So red LED is connected to port 1.0 and blue LED is connected to port 1.1. So it is the connection which I have made, but you can able to make it in terms of your own connection. So for our understanding, I have made in this fashion. So P1.1, it should be on for 1 second. First it should be on, and after that it should be off for 1 more second, right? That is what the question is. So after that, if an interrupt int1, so while you are studying about 8051, int1 is an external interrupt which is given in terms of a key, button key in your kit, so that if you are going to press that button, so P1.0, which means your red LED should glow for 1 second, and after that it should be turned off. So the process has to be repeated again and again in a never-ending loop. This is what our condition is. So we will try to consolidate what are the things we have. So crystal oscillator frequency, it's default for all. So we have access in terms of, we have to access port 1.0, which is going to be a 13th pin with your connector. So P1.1, which is your 14th pin by your connector. So 13th pin is going to be a red LED and 14th pin is going to be a blue LED. Right. So after that one, timer 0 has to be used, and after that we have to create a 1 second delay. All the things is having 1 second delay. And after that, interrupt 1, right? So it is an external interrupt. External interrupt. So we have studied already about interrupt service routine, right? So if you are going to press this interrupt, which is going to be interrupt 1, it has to jump to the interrupt service routine. So this interrupt service routine has some things with respect to memory location. So this memory location should be from 0013. It is having some instructions, and after that, whenever it is having a return I command, it is going to jump back to the next instruction of the program, which is there, right? So this location is going to be moved inside your stack. So after that, whenever it is going to identify its return button, it is going to take the information from stack. Right? This is called as interrupt service routine, right? So we'll try to have a quick glance of what are the things we have seen till now. So this is our kit. So this is your power pin. So we have to make use of this power pin, and we have to take it for our consideration. So after that one, we will try to make use of this connector. So we are having a connector here, so with which we are going to make access in terms of ports. And after that, we are having our interrupts, right? So this is what our question is. So interrupt 1, which is port 3.3, this interrupt 1 is there. You have to press this key. If this key is pressed, red LED should glow for 1 second. That is the program, right? So this is our reset, and this is our hero, which is going to be 8051. And after that, this is your crystal oscillator. So max 232, which is going to be your TTL PC interconnection, which is going to be in terms of logics. We have already seen in theory classes, so it is going to be that pin. So this is an PC connector, so that your Keil, whatever program you are going to running through Keil, it has to be interfaced here. So it is going to make use of RS232 pin connection. It is a serial port communication for our input. So with this idea, we can able to jump to the next. So we are going to access in terms of your ports, right? So if you are going to access your ports, So we have to make use of our pins which is readily available. So we are having this pin here, right? So we are having 13th pin. So 13th pin is going to be your P1.0 with which your red LED is connected, and 14th pin is going to be your port 1.1 to which your blue LED is connected. So in terms of program, blue LED should glow for 1 second repeatedly whenever the interrupt button is pressed. So this blue LED has to stop its operation, and after that red LED should glow for 1 second, and after that it should stop. After it stops, your blue LED should glow again. The thing which has to be happening while you are running an interrupt. Right? So this is a pin configuration. So it has to be looking our side, so that it is going to be pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So this is your red LED and this is your blue LED. You have to connect to your blue LED, and after that one, this ground has to be connected to both the LEDs for its glowing, right? So this is the pin connection which you have to make. You can able to make use of your breadboard for your connections. So with this, we can able to move to next one. So what are the interrupts we have? We are having 6 interrupts in 8051. So which is going to be a reset, which is going to be power up reset. So when you are going to press your reset button, so it is going to enable all your ports to FAF, and it is going to move your data memory to 00 and your program memory to FAF, all those things is happening, right? So it is an interrupt in terms of your 8051. It is your first interrupt. And after that, we are going to have 2 interrupts in terms of your timers, right? So timer 0 and timer 1. So while timer 0 stops its completion of your timing, so after it is completing its timing, so it is going to be enable your TF0. After enabling your TF0, it is going to create an interrupt, right? We have seen these things in terms of your block diagram also. So after this one, it is going to be enabling your TF1 overflow flag. After that, it is going to create an interrupt, right? This is also an interrupt. So while you are using in terms of port 3.2 and 3.3, these things are going to be your external interrupts, which is going to be provided in terms of switches. We have already seen in terms of our kit, right? So port 3.2 is going to be interrupt 0, and your port 3.3 is going to be interrupt 1. So in programming, we have to make use of this port 3.3 interrupt 1. So for your serial communication, we are having one more interrupt. Whenever it is completing it, receiving and transferring, it is going to create an interrupt. So reset 1 interrupt, and after that timer 0 1 interrupt, timer 1 1 interrupt, and after that 2 external interrupts 4, that is going to be 5, and serial communication is going to have an next interrupt which is going to be 6. So total 6 interrupts we have. So after this one, so we have all the interrupts are having a clear vector address. All the interrupts are vector interrupts. So whenever this interrupts is happening, it is going to move to the specific memory location inside your memory, right? So we are having external 0 and we are having timer 0. So you are going to create this interrupt, right? Interrupt 1, external interrupt 1, INT1, right? So if you want to create this interrupt, after creating this interrupt, it is going to jump to this memory location. So whatever is there, it will try to execute that one. And after completing, whenever it is finding return I, it is going to jump back to its original program sequence. Right? This is how this is going to work. So we have to enable your external interrupt, and after that, it has to jump back to your memory location of 0013H. And after that, it has to again revert back to its original program after completion of this interrupt service routine. So for an interrupt to be perfectly running, there should be an interrupt enabled register. So in terms of your interrupt enabled register, EA is going to be showing that interrupt is being in operation. So ES is going to be for serial port interrupt, and ET1 is for your timer interrupt, and EX1 for your external interrupt, and after that ET0 for your timer interrupt, and EX0 for your external interrupt, right? So in our question, so it has been given you have to make use of your external interrupt 1, right? This is what the question is. So if that is going to be happening, so we have to understand that interrupt will be enabled, right? So whether it has to be 0 or 1, interrupt, it should be enabled, right? So it should be 1. So it is don't care conditions. So whatever we are going to give, it is not going to be your issue. So I can able to give it as 0, 0. And after that, whether I am going to enable my serial port interrupt, no. So it should be 0. And after that, whether I am going to enable my external timer interrupt of 1, timer 1 interrupt, no. This is also 0. So whether we are going to create an interrupt using your external interrupt 1, yes. So this should be 1. And all other things should be 0, 0, right? So your interrupt enabled register, so it is 8, and after that this one is 4, right? So your interrupt enabled register should be getting the value of 84H. So in order to make use of your external interrupt, and how it is going to make use of that external interrupt 1. So we have to configure your interrupt enabled register to be 84H, right? We have seen already these things while you are discussing in terms of your control word in 8086 as well as your timer concepts, all those things, right? So it is going to be the same. So after that one, so this is already we have discussed, right? So in terms of solution, we are having one more problem. So we are having 1 second delay. So if you want, crystal oscillator frequency is going to be 11.0592. So this is going to be your frequency. If you are having your time period, so if try to create an inverse of it, so it is going to be 1.085 microseconds. So maximum delay which we can able to create with our timer which is available to us. So minimum value we can able to set it from 0000, so that it can able to start its count and it can reach its FFFF. All these calculations we have already made in your previous videos. Just go through those videos also if you want more clarity. But the minimum count it can able to start at is with 00, right? So minimum count, if it is going to be starting from 00 to FFFF. So if you are just multiplying 655, so it is going to be 2 to the power 16, right? 16-bit interrupt. So 2 to the power 16, so that along with your values of 0000, after that getting multiplied with your time duration, which is going to be 1.05 microseconds. So we will be getting 71.1065 milliseconds. So maximum delay we can able to create from that timer without using loop will be 71.1065 milliseconds only. But I want 1 second delay. If that is the case, I have to identify what value I should multiply it, right? So if you want to identify this value, so this value can be brought this side. So 1000 divided by, it's millisecond, right? Both the things convert into millisecond. 1 second is 1000 millisecond. So 1000 divided by 71.1065, it is going to be 14.0634. So in order to make this to happen, so I have to iterate the loop 14 times. So to create a delay of 1 second, right? So in 14 in terms of hexadecimal will be 0dh, right? This is what your hexadecimal value represents. So we have to make this THTL to be 0, 0. And after that, this count has to happen again and again. 0 to FF count has to happen again and again. This is 1. And after that, it has to again count 2. After the 3, till it has to reach its 14th count, it has to count so that we can able to create a time duration of 1 second, right? So this is what it means. So we can able to create this time duration so that we are able to iterate the loop for 14 times. So we have already seen this, how to create a delay using our timer. So we will directly jump to that program. So we will start with origin 000H where your program starts. And after that here, so since we have an interrupt service routine, which means, so interrupt service routine for your interrupt 1 will start at 0013. We have seen our interrupt vector interrupt address, right? So which is going to be 0013. So that interrupt service routine should be having one origin, right? So this origin is going to be 0013 at which your interrupt service routine starts, right? So your program is starting from 00. So interrupt service routine, it should be executed only when you are going to press this button. Other than that, it should not execute. So if you are directly giving it inside your program, it will be executed always, right? So it should not happen. So what we have to do, we have to use a jump statement so that we are going to jump to the main program. So your main program starts from here. So this is your interrupt service routine program which has to be happening. So after that one, before it is getting executed, only main program should execute. So that I am jumping to main. So I am using L jump, long jump, right? So why I am using long jump? So if your memory is more than 2 kilobytes of data, so if you are going to move in terms of a large space, large location, I have to use the L jump. Else I can use S jump also. If the memory location jump we are going to make is very small in terms of program memory, we can able to make use of S jump also. So I have used both the jumps, which is going to be L jump as well as S jump here. Right? So both the things I have made because the jump is going to be from here to here. So in terms of program 0, I'm going to make it as L jump to main, right? So we can able to make use of both the jumps here. So at this point of time, I have to enable my interrupt, right? So which is going to be interrupt enabled register, right? So we have already calculated it should be having 84 Hz, so that your external interrupt 1 is getting triggered. Whenever it is going to be triggered, it will jump to its ISR, which is going to be in 0013. So it has to be getting its value, right? And after that one, I have to make use of my timer to create 1 second delay, right? So we have already seen many programs how to determine your T-mod register. So if your T-mod register is going to have the value of 0, 1, which means you are going to make use of your timer 0, and in terms of your mode 1, right? So mode 1 is going to be 16-bit mode. So correspondingly, we are going to make use of that T-mod register. So we have to start it from minimal value, right? 00H. So TL is going to be 00, TH is going to be 00. It is a minimum value which we can able to give it for TH and TL. So after that one, if you want to create a delay, it has to jump there. Now delay is not needed, right? Initially delay should not be there. So I am going to set my byte. So set byte P1.1. So which means I am going to enable my blue LED. My program starts here. This is what my first condition. So I'm keeping all the things ready in terms of timer. And after that, I am going to set P1.1. So this blue LED is going to glow for 1 second, right? So I'm using a call delay. So if I'm going to use a call, so it is going to be acting as an interrupt service routine. So this interrupt service routine is going to jump to the memory location wherever it is given. So I have given delay here, right? So delay is actually here. So this program is same in your previous program. You can able to refer this, or we can able to give a glance here. So R1 register is going to get the value of 0D. Why? Because this loop has to repeat 14 times to create a delay of 1 second. We have already seen this calculation, right? So which is going to be taking 14, 0D. And after that, it is going to be set by TR0. TR0 is getting set, which means timer 0 is going to start its count from 00 to FF. So this is going to be jumping again. So it is going to check the condition of your overflow flag of timer 0 whenever this is completed, which means that timer which is going to be starting its count from 0000 to FF is getting completed. It is going to be jumping out of the loop, else it is going to be repeating in the same loop again and again. So after this point, whenever it is completing, overflow flag is going to be set so that it is going to be 0000. Count is from FF, it is completed, right? So after completing, I have to make my TR not to be 0 and TF not to be 0, because previously all the things are set to 1. So I have to make things to be 0 exactly here. And after that one, first time it is completing, right? It is going to create 71 millisecond only. So I have to repeat the loop 14 times. So I can able to make the delay of 1 second, right? So I have to make use of this do jump no 0, which means till your R1 becoming 0, I have to repeat the loop again and again. So if R1 is not going to be 0, it is going to jump to max. So where max is here, here it is there. So again your TR0 is going to be enabled so that your timer is going to start its count from 00 to FF, and after that this is going to be repeated again and again so that we will be getting those values. So with this values, so we are going to get the values one by one. After that, we are going to move the loop for 14 times. So all those things is going to happen in a loop again and again. And after that, whenever it is going to identifying this return, so it is going to be jumping back to this statement. So I am clearing my port 1.0. After completing 1 second, I am going to switch off my blue LED. I am clearing my port 1.1 where the blue LED is getting connected. And after that, I am creating an equal delay. So it should be turned off for 1 second, right? And after that, it has to jump back here. So that your blue LED will blink on for 1 second and off for 1 second. That is what the question. So first thing is over. So first requirement of your program is over. The blue LED is blink on for 1 second and it is going to off for 1 second. And the next problem which is given to me is going to be if I am going to press an interrupt switch in your kit, interrupt 1 switch in your kit, it has to turn on your red LED for 1 second and after that it should be off. That is what the condition is, right? So I am creating an ORG which is going to be 0013. So we know that whenever an interrupt 1 button is pressed, it is going to jump to this memory location. So in this memory location, I am setting my P1.0, right? So what it means, this red LED is connected to this one, right? So this is going to be turned on. So I am calling the delay again, which is going to create a delay of 1 second. And after that, clearing my red LED. So the red LED will be turned on. Here it is on, right? So till this point of time, when the red LED is glowing, your blue LED should not glow. That is what the condition is, right? Because whenever it is trying to execute an interrupt service routine, your main program should not run. That is what the condition is. So till the interrupt service routine is identifying the return command, your main program should hold, and after that interrupt service routine should be executed. And after interrupt service routine is getting executed, whenever it is going to identify RETI statement, it is going to jump back to the main program. So main program is here. So again your blue LED should start glowing. So this is what my condition is. So I have to make use of this condition and I have to get it done here. So I can able to start it here. So I can jump directly to Keil program. So while you are moving inside your Keil program, so this is what the program. So I have given the same program here. So this is for your interrupt service routine, and this is for your main program, which is going to be starting from ORG 30030. So it is going to be jumping from here to here. So after that point, it is going to be having L jump main. So it is having a delay of 30, right? So this is a long jump. So if it is going to be short jump, it is going to be within the iteration itself, right? So it is a short jump. So like this, we can able to make use of our programming methodology. So it should be having 0030, origin 0030, and this is having origin 0013 because it is an interrupt service routine which is going to be looking for the memory location of 0013. So this is the program for creating 1 second delay, right? This is how your program is going to run. So after coming here, so what we can do, so we can able to make use of our programming. So before getting into hardware, we have to make sure of few things, right? So we will click on target. So we will see whether the device AT89C51 is selected. So it is selected. And after that, in target, we have to see whether your crystal oscillator frequency is 11.0592. Yes, it is 11.0592. And after that, I have to enable on-chip RAM and on-chip ROM, both the things. It should be enabled. Okay, I have enabled both. And after that, I can move to debug mode. In the debug mode, if your use simulator is getting on, so you have to click on your use Keil monitor 51 driver. You have to select this one. And after that, go to settings and make sure of your active COM port. So if you are going to understand of your active COM port, go to your device manager. So in your device manager, we can able to see which COM port is currently active. Right? So COM port 3 is currently active. So I have connected my 8051 to COM port 3. So I have to make sure this COM port 3 is enabled here. So here the baud rate is 9600 because this is making use of your serial communication. Your baud rate will be 9600 bps bits per second. So it is going to send 9600 bits per second from your PC to your 8051. Is it clear? So we can move to the real-time simulation, so that we can able to make into two individual halves. First half is going to be for your program, and next half is going to be for your real-time kit. So now half of a screen is for your hardware and half of the screen is for your program. So I think program is visible for you here. So after that one, I have to click on translate, and I have to build it, and I have to rebuild it, and I have to press my debug button so that my port is getting connected. Yeah, now the connection is being made, so this is not needed for me now, so I can remove this one. So this is what my major concept is going to be here. So I can able to run this one, and I can able to see in terms of your program how it defines in terms of your hardware, right? So now you can see, so you are going to have, so in default, when before running your program, so you can able to stop your program and you can see. So I should not give like this. So if I want to give it, so press your reset button in your hardware. So press it. So after that one only, you have to get out of the program. Before that, you should not click on reset from your program, right? So if you are going to run this command, or if you are going to run this program, before running, you can able to see both the LEDs are turned on position, right? So blue LED is also glowing and red LED is also glowing. So port 1, every port will be having the value of FF, so everything will be on. So after that, I can able to run this one. So we can able to see now. So till now, I have not pressed my interrupt button, right? So my port LED is always on now. So my blue LED is blinking. So my main program is getting executed, so that I can able to see my blue LED is glowing here, right? And after that, red LED is being in on position because till now I have not pressed my interrupt button. So in default, it is going to be 1 always. So whenever I am going to press this interrupt 1, so this is interrupt 1 switch, right? So if I'm going to press this interrupt 1 switch, so this has to stop its operation and this has to enable its operation, so that it is going to blink for 1 second. It is going to be on for 1 second, and after that it should be turned off. That is how I have programmed, right? So if I'm going to press this one, see, so it is going to be your blue LED is going to stop its operation, and after that one it is going to be pressed again, so we can able to see. Yeah, so blue LED is not functional, so it is not blinking. So it is going to be having in terms of your red LED only, so that whenever I am pressing this button, so this is going to be on for 1 second, after that it is off, right? So after that it is going to be on for 1 second, it is off. So which means if I am going to press this button, your interrupt service routine is enabled. So after getting this interrupt service routine enabled, I can able to see my red LED is glowing if I am going to press this button. So ISRS routine, and after that it has to complete its operation and has to get it back. So like this, it should be doing its operation again and again if I am going to press my interrupt, right? So this is how we are going to do the forthcoming programs also. So if I am going to make use of this interrupt 0, so correspondingly I have to make use of that specific memory location, so that that memory location can be accessed, and I can able to connect one more LED to that one. So if this key is pressed, one more LED color LED should glow. If this key is pressed, one LED can glow. So this is going to be common for all the things now. So if any interrupt is being given, so that specific interrupt service routine memory location is accessed, so that once that specific program only will run. So we can able to check that also again. So 1 second, after that is switched off, right? So like this, we can able to do any kinds of program in terms of your interrupt service routine. So beyond this, you can able to do in terms of other interrupts also. So when your timer 1 is getting its operation completed, so it has to jump back to the interrupt service routine and it can able to do some job, right? Like this, you just try our program. So after that, we are having, while theory class I have explained in terms of your priority register, right? So the first priority is given to your interrupt 0, and after that your timer 0, after that your interrupt 1, after that your timer 1, after that your serial port. So now try to shift the routines. So change the priority and see how it is working, and we can able to check in terms of your hardware programs also. Yeah, that's it in this video. We can able to see the remaining things in forthcoming videos. Thank you for your patient listening.